A small recap of yesterday's session. Yesterday's session, we discussed on configuration management and then source code management. So configuration management, why we need is when you are handling thousands of servers. So we cannot log into each server, even we cannot install the software through Jenkins. Okay, so we got something like Ansible server that connect to all the servers, like thousands and lakhs of servers. Also it can push the configuration is nothing but ultimately we need to deploy the application developed by the developer into some server. So we need to prepare the server. Preparing the server is nothing but creating the server, install Java in that server. So without server preparation, developer cannot deploy his code. Okay, so that is why we need to create the server first, install Java or whatever, like .NET, Node.js, Python, whatever the programming language the developer is using. Okay, and then we need to create some users, for example, for developers to access the server and push their code, and some directories, and yeah, so these things can be done through the continuous integration. We will discuss that today. So the point is, before deploying the application, you need to prepare the server. So that preparation can be done through the configuration management. Okay. And we discussed the difference between shell script and Ansible, because in shell script, you have to log into each server and then run the script, but Ansible can connect to all the servers at a time. It can push the configuration. Okay. And yeah, when the application is running, so if you want to change the application version also, Ansible can do that deployment. So Ansible can be used as two purpose. One is configuration management and another one is deployment tool. Okay, that we will again discuss anyhow. And later we discussed source code management. Git is popular because of we can keep the code secure and backup. Version control, you can have multiple versions of your code. And then collaboration, if multiple persons are working in a team, so then Git is used as collaboration. Everybody is pushing their code to the Git, and here we can merge it. Okay, and you can track who changed what. And review mechanism is also very popular in Git, that is PR. So whenever you are releasing the new features, you create a new branch and you do the code change, and finally you will merge it into the master. While merging, you will raise a pull request so that everybody can review. Okay, and we discussed yesterday something like AWS DevOps and Azure DevOps as well. Yeah, GitOps is nothing but whatever you are doing, either a developer or operations guy or testing or DevOps cloud, whatever you are. Okay, you have to, you should not do anything manually. You should keep the scripts in GitHub or any Git like Bitbucket, GitLab. So then that is called GitOps. So Git is your single source of truth. Whatever you do, that should be in the Git. So today we will discuss about build and then continuous integration. That is CI. First, let us discuss on build. Okay. So developer is developing the code. So ultimately, it should be converted into a single artifact. Okay. If you see, our Windows OS is also .iso format. So that is a single file. Do you think that's a single file? No, in background, it has thousands of files included. Okay. So what is this build is? The developer is writing the code, but we don't know whether he is writing properly or not. So that is why programming languages have something called compile. Okay. So if you compile, then you can say the code is good. Okay. So first thing you should do is compile the source code. Okay, source code is nothing but the developer code. So if you compile, if no errors, then it means the code has followed proper syntax. So after compile, you need to do the package. Package is nothing but convert all files into a single file. So for example, let us take Java projects. So Java projects, first you will write the code and then compile it and then package it. So the ultimate result will be .jar. Okay, for example, if it is restaurant project, then it is restaurant.jar. So inside this jar file, that is compiled code. It can be any number of files. Okay. So this restaurant.jar is called as artifact. Okay, so this is artifact. Similarly, in .NET also, so when you do the build automatically, so it will compile in background and it will give you package. So that is of .zip extension. Okay, so .NET, Python, Node.js, everything will come as .zip extension. Okay, so this is also one of the format, just like jar. So if you know .zip very well, if you extract it, you will get many files. Similarly, if you extract jar file, you will get many files. So those are the compiled source code. So this is called build. And here there is something called as dependency resolution. So what is dependency resolution? Every project or every code is dependent on some other libraries. For example, every project is dependent on some libraries. Okay, so you cannot develop each and every line of your code. You need to use the libraries which is already developed by someone else in the internet. Okay, for example, if we see Java project dependencies. So we will get okay. So as a DevOps guy, you don't need to understand. But convinced to this point, every project is dependent on some other libraries. So those are called as dependencies. Okay, so that is like no exception for .NET, Python, Node.js, React.js, any project, any language is dependent on some other libraries. Okay, so how can you get those libraries? For example, in our Java server, in our Linux server, if you install Nginx, it will download and install a lot of other packages also. So those are called dependencies. Similarly, if you are working in any .NET, Python, Node.js or Java, so your project is dependent on many other libraries from the internet. So those are called dependencies. How can you resolve those dependencies is, so every project has some build file, that is for Maven, for Java. So we have the build tool as Maven. Okay, and we have many other like Gradle and, but Maven is popular. So the build tool is form.xml. Similarly, Node.js has build tool. So that is npm. The file name is package.json. So I'll show you soon. Similarly, Python has build tool. That is pip. The file name is requirements.txt. Okay. So .NET has also one tool that .NET build file. I forgot this. What is? Okay, that is .sln project.json, whatever. This is called as NuGet. File name is project.json. So the concept you should understand is every programming language has some build tool, okay, and it is referring one file Now let us see all these files, sample pom.xml, GitHub. If you type like this, so in this pom.xml, this is XML format. Here you get the dependencies. What is the group ID? What is the artifact ID? What is the version? So this means these will be the libraries that will be downloaded from the internet. So your build tool responsibility is to download the dependencies from the internet. You go for Node.js or package.json. It will refer from package.json. You can see here the dependencies are expressed with version 4.13 and node engine. So this is the dependencies. So including to that, you will mention what is your project name, what is the project version, what is the description, and everything you will mention here. Similarly, in maven pom.xml also, you will refer what is your group ID, artifact ID, what is the extension of your code, that is .jar, and your project name and your project URL and the properties. So just understand for now. So you will always have one file that you declare the dependencies and project names and versions, everything in this file. So without this file, you cannot do the compile and package. Okay. So finally, every project, every language have one build file. So you need to refer that file for dependencies and packaging. Okay. For example, now you have this pom.xml. So how can you build this Java project is if you run mvn package, then in background, it will do the compile. It will create the .jar file. So if you have any errors in the programming language, then the compilation will be failure. Similarly, Node.js will have npm build. So then this command will check whether package.json is exist in the directory or not. If it is not exist, then it will give you an error. Okay, if it is exist, it will download the dependencies from the internet like this, and then it will convert your entire project into .zip file. So this is about build. So finally, build is nothing but compile your developer source code and then create a package out of it. So if the source code is compiled successfully, then you will automatically get the package. If the source code is not compiled properly, then you will not get the package. You will get an error. Immediately, you will tell the developer your compilation is failure. Okay, please check the programming language, programming for some mistakes. And that will tell you also where the code is wrong. So this is about build tool. Okay, so mainly for dependency management and then packaging your application. So we completed the build and you assume we got the package or artifact. So this we call it as artifact generally. So and next thing we will discuss on continuous integration. So this is the popular concept CI in DevOps world. So everywhere you see CI/CD, and everyone will say that DevOps is nothing but continuous integration. So what is continuous integration? What is integration, first of all? So for example, 10 developers are writing a code, thousand lines of code or some hundreds of files. Okay. So ultimately you need to make it into a single format like .zip, .jar. So that is continuous integration actually. But why it is called as continuous integration is, for example, 10 developers are there. So what we said about DevOps process, even a single line of code should be deployed on the same day. How can you deploy that automatically? So that is through continuous integration. You cannot do this. It cannot do this manually, right? For thousands of time. So what you do with continuous integration is, so when developer commits the code into Git. So yesterday we discussed, right? When, for example, developer one commits the code into Git. So what we do is, let me remove this. And developer commits the code into Git. So this will automatically trigger a pipeline. So that is Jenkins pipeline. So what that pipeline will do is, first it will compile and it will build. So after build, it will get the artifact. So then it will connect Ansible. Inform Ansible to deploy this artifact. Okay, so or else till here only. Continuous integration is nothing but integrating your code into a single artifact. So that is continuous integration, but you don't do it manually. You will do it through the Jenkins. So here there will be a Jenkins pipeline. So there will be stages. So this is the stage here. First, clone the code. So this is Jenkins. Jenkins continuous integration. Clone the code. So from where it will be cloned? From here. And once clone is done, then you build it. Once build is done, you create the package and store the package. So till here, this is called as continuous integration. So Jenkins is a popular tool. In your interviews, you will get the question, what is continuous integration? Continuous integration is a process of continuously compiling, building, creating the artifact and storing the artifact into some location. So where you store is, so this is build. This build is integrated with Maven, for example, Java project. So this is Maven tool. And you create the package. And you need to store it. Where you store ultimately, so there is something else that is called as Nexus or JFrog. Okay. See here, you are integrating multiple tools with Jenkins. One is Git, another one is Maven, another one is Nexus. So in your Jenkins pipeline, you have the integration to multiple tools. For build, you are integrating with Maven. For cloning the code, you are integrating with Git. And then your artifact is nothing but Nexus or JFrog. So just like you are storing the code in GitHub, similarly, you have to store your package into somewhere that is called as Nexus. Okay. So here your Jenkins server is integrating multiple tools in a single pipeline. So how is it integrating is through the plugins. So here you should have Git plugin. And here it should have Maven plugin. Here it should have Nexus plugin. Okay. So originally Jenkins is a simple web server, simple application, a simple web application, but the power really comes from the plugin. If you develop a plugin for your project, then Jenkins can easily integrate with your project also. So the power really is in plugin. Plugin is where Jenkins can interact with any other system or tool in the internet. Okay. For example, here 10 developers are working at a time, 10 developers are pushing code to the Git. So then how can you do this continuous process? For each line of code, we need to build it, we need to compile it, and then we can create the package. So that is how it is done, is through the Jenkins CI. CI is nothing but continuous integration. That is why we call it as continuous. Continuous is nothing but without your interaction, manual interaction, this will happen automatically. So as a DevOps guy, you don't need to manually run these commands. Okay, you don't need to run manually these commands. This will happen automatically in the background. So this can be Jenkins, this can be GitLab, this can be GitHub Actions. It can be anything, Bamboo or Hudson. But the process is, the concept is same. Whenever developer is changing a single line of code, okay, even if he enter a single space and then push to the GitHub, so that is, we call it as a change in code. So change in code definitely should trigger a pipeline. So that will clone the code, that will compile it, that will build it, package it, and then finally create the artifact and push it to the Nexus. Okay, so that is why our codes are now error-free. Earlier, we were getting a lot of defects because we are not checking these things continuously. But now, even you change a single line of code, it should be checked properly. So then if this phase is success, then we can call it as CI is success. Okay, so at least your code is able to compile properly and it can create the artifact properly. So this is the continuous integration. The popular tool we have now in DevOps is nothing but Jenkins. Okay, in Jenkins, we write the pipelines like this. So just like I explained now, so we'll build it and you can have any number of stages. Okay, you can see clone or checkout, build, test will come to that, and then you will push it to the Nexus till that it is called as CI pipeline. Okay, so but the power of Jenkins is really in the plugins. So if you install plugin, then Jenkins can easily interact with the tool. So Jenkins is also called as orchestrator. Okay, so just like your Ansible can interact with any number of servers, Jenkins also can interact with any number of tools, provided if you have the plugin. Okay, so then it's your wish how you will write the pipeline. Okay, so any questions till now? You can raise your hand. Yes, Sai Krishna.
Shiva, see, in Jenkins, we install all these things or what, like how it happens.
Yeah, we need to install those plugins.
So if we install, these are the works of these tools or whatever these things are. So cloning is the work of Git and build is the work of Maven.
Yeah,
Artifact is the work of Nexus or JFrog.
anything. So you have multiple tools in the market, right? So we have Gradle here. We have Ant here.
So
But
anything, but
yeah,
with these things, you will usually clone, build, or artifact.
yes, correct.
Oh, so all these things are installed in Jenkins.
Yes, these plugins are installed in Jenkins. So
Oh, so
without Jenkins, earlier what we were doing is we were logging into the servers manually, Linux servers, and we were installing Git, we were installing Maven, we were installing Nexus, then we are running the commands one by one. So
Okay,
now
so this
with
is
CI, you can create the pipeline, and then once the pipeline is created, you can use it infinite number of times.
so the combination of these things is called pipeline.
Yeah, this is CI pipeline. We can call it as CI
Oh,
pipeline.
okay.
So we have few more things added that we will discuss anyhow.
Okay, then what is Terraform?
So Terraform we will discuss later. So
Okay,
that
okay,
is
okay.
different.
Thank you, thank you, thank you.
Okay. Yeah, Vasanta Krishna.
Yeah, as a DevOps developer, this is our responsibility to check with the developers or somebody enterprise level, what are the tools they are using for this, all these purposes. We need to install those softwares.
Yeah, so before, yeah, please continue.
Or that is already, that is infrastructure already installed those plugins, just we can use those plugins and create the pipelines.
Okay, so before project is getting ready, so everyone will discuss, right? So developers will discuss what is the architecture of the project. Similarly, DevOps team, everybody will come and discuss what are the tools and technologies we are going to use for this project. Okay, so that is called the defining stage or defining a design stage. So at the design stage of the SDLC model, so you will decide what are the programming languages, what are the tools and technologies and their versions you are going to use. Okay, so at that stage you decide, for example, we need to use Jenkins. Then if you have Java project, you can go for either Maven, Gradle or Ant is anyhow outdated, and you can discuss and decide everything forefront. So once the developer is starting their code, by that time you should be ready with all these plugins.
Okay, so
okay.
that means as a because as a DevOps engineer is came from the non-technical background or coding background, how it will be suggestible which type of the language, which type of the code which type of the tool we need to use it.
You don't need to decide. You don't need to decide. Architects will take the decision.
Okay.
Okay. Sheikh Kaiser.
Good morning, sir.
Yeah, good morning.
Sir, this one package and artifact both are same, sir.
Yes, both are same. So generally we call it as artifact.
Okay, sir. Thank you, sir.
Okay, most welcome. Lavanya CH.
Hi, Shivaru. Good morning.
Yeah, hi, Lavanya.
Actually, this compilation, building, these are developer part, right?
Yeah, so he will also check. He will also check in his mission while writing the code in his laptop. So, but it is our responsibility also to build it in the pipeline. So
okay,
consider
whether it
this
is
is one more check.
perfectly or not, that all things we have to check.
Yeah, so just check. This is one more check.
Okay.
So developer
And
will
one
check.
more thing, this is for every environment.
Yes.
For every environment, this process will repeat.
No. So that is one of the best principle. If you do it one time, the same artifact will be shipped into multiple environments.
Okay. And these tools will vary with programming language. Is it so?
Yeah, that's what I discussed here. Every program language, this is not a big tool. This is a simple command actually. So if you install this package, you will get that command.
Okay. This one will be decided by DevOps architects, right?
I mean, DevOps architect will decide something. Developers will decide something. So developers will decide this one. So this form.xml, package.json, requirements.text, project.json, all these things are developed by developers. Okay.
Yes.
So while deciding this build tools, we don't have any decision making power, because it is their programming language. They are going to write, so they will decide.
Okay, we will be informed. We have to install those things.
Yes, correct.
Okay, before for small projects also it will be applicable, because what I know, build will be taken care of by developers, some senior developer, something like that. What I know. So
Yes.
is it now?
Yeah, that's what
It's
I'm
coming
saying.
to DevOps.
Yeah, no, that's what I'm saying. Developers will check while writing the code. They will also compile in their laptops.
No,
Okay.
what I mean is, see, in one team, so many developers will be there. They will do individual development, and they will integrate through something, some integration tool, and I mean, like Git, TFS, like that. Some senior developer will do final build. That's what I know.
No,
But
so
now,
let me tell you. So
okay,
actually, build is nothing but compile and package. That's all.
yes,
Nothing
mm,
much complex here. If your project is compiling successfully, then obviously
mm,
it can create the package properly. So before
okay,
pushing it into the GitHub, they will also check in their laptops.
mm,
Okay, once that is good, then they will push into the GitHub. Again, we will do another check here. So whether they do it in their laptop or not, that is not mandatory. But here it is mandatory. Okay,
okay,
because from here you are pushing the code into the Nexus, right? So here it is mandatory. So if developers are also doing in their laptops, that is good. If they are not doing also, here we are doing it. So this is the
okay,
integration. Integration is nothing but your code is able to compile and it is integrated into a single artifact. So that is called continuous integration.
okay.
Okay. So when it comes to the controls and compliances, that anyhow we will discuss, but just understand the high level concept.
Okay, and one more thing. Yesterday you gave an example, like some errors came suddenly, instead of 100 rupees, 1000 rupees.
Yeah.
That one, how, as a DevOps engineer, how we will know?
That is our DevOps engineer is it is our responsibility to just to deploy the application. But that instead of
Yes.
100 rupees, it is showing 1000 rupees. It's not the DevOps mistake. It is purely programming mistake.
That how we will know? I mean, through some testing artifacts or something like that? No?
So if your application is not opening in the internet, then it is completely DevOps person. They should check first.
Yes.
If
Yes, that I understood.
if your application is opening in the browser and you are able to access, there is no issue in access, then it is not a DevOps mistake. So now it is the
Okay.
developer responsibility to go and check first what's happening in the background. So they will open the application logs, they will check the databases. Okay. If application is not
Okay.
responding, then immediately you are the point of contact.
Okay. Thank you. Got
Okay.
it.
Yeah, most welcome. So now let us discuss something else and then we can answer more questions. So now you got it clear. Build is clear and then continuous integration is clear. So this is the scenario at least 6 years back. You are cloning, building and creating the artifact. So there is something called shift left. So this is popular DevOps principle in the DevOps world now. What is shift left? Okay. So in earlier days, what we were doing is you are doing CI and then you are doing deployment. Then you are doing the testing, scanning. Scanning is nothing but like any issues in the coding, not functionality. So some developers, they can write good code. Some developers, they can write bad code. Good code also will work. Bad code also will work. But if you write the bad code, hackers can get into your system easily. Okay, so that is why we should scan it. Okay, scanning is nothing but suppose you are entering to the shopping mall also, they will scan you. So good shopping mall, they will scan you properly. Bad shopping mall, they will directly allow you to enter into the shopping mall. So, but the mistake is, allowing you with some explosions, right? And once you enter into the shopping mall, if they test, what is the issue? Okay, so let me do a simple example again. So mall, you are entering into a mall. First, they are not checking. They are not checking at entrance. So this is one mall. Then we have mall 2. This is mall 1, for example. So this is mall 2. They are checking before entering. So which is good? So obviously mall 2 is good, okay, because they are scanning you before you enter into the mall. Similarly, earlier days, what we were doing is once you deploy the application into the production itself directly, then we were testing and scanning. Okay, so or at least scanning. So then what we understood, so instead of deploying into the production and then you are scanning for the issues, why can't you directly scan for the issues in the development stage itself? Okay, so just like mall 2 before entering. So before deploying or before doing the integration itself, just scan for the issues. So that's why we called it as source code scanning. So this is SonarQube is very popular and there is no alternative till now. So this one will check each line of every line of code. Okay, and give you results. So now let us see SonarQube. So it can check your code and it will give you the how many bugs, how many vulnerabilities. So this report it will give you. Okay, so it will check each and every line of the code and it will give you suggestions whether you are writing the code properly or not. Okay, so this is called as static source code analysis. Static source code analysis. And another thing we have called as static application security testing. So this one is to check the coding standards. Okay, so this one is to check the security like unnecessary variables. Or some like unnecessary access. Okay. And something like you are printing the passwords in the code. Okay. So generally we used to write print statements heavily just to understand what is happening or for debug purpose. So it will check each and every line of your code in the security level. And it will give you the results. Similarly, we have something called as open source scanning. So while discussing the build, so I told you we will go for dependencies. So these dependencies are from the internet and you don't know what is inside the dependency. Maybe they have some malicious code. Okay, so it will check dependencies are official or not, or it has issues. So finally, this one you are implementing scanning, all types of scannings. Okay, your source code scanning, your security scanning, and your libraries, whatever the libraries from the internet you are using, it will check each and every part of your system and it will give you the report. So now this is called as shift left. Okay, so earlier it was right side. Once you deploy, we'll go for scanning. But now, while you are developing itself, we are doing the scanning. Then you will now your stages will become clone, compile, build, scan, and then package. Okay, or itself. This is itself is scan and then package. Package is nothing but final build, and then push to Nexus. Okay, so you integrated scanning in the CI stage itself. Now it is called as shift left. Just like MOL-2 is becoming good, your code is also becoming good before going for deployment. So this is called as shift left. So now if you keep this word in your profile, shift left, then definitely interviewers will get more excited, because they will definitely ask you, what do you mean by shift left? Then if you tell this answer, so then they will be surprised and they will be happy with your answer. Definitely they will offer you good position because you know the concepts very well. So instead of working blindly, so you understand what is shift left, what is the good standards to work as a DevOps engineer. So now this is called as continuous scanning. Okay, for every line change of the code, you are compiling it, you are scanning it, and then you are creating the package. So this is CI. So not only scanning here, there is something called as unit test. So unit test will test the code, test the developer code. Okay, so now this will happen like clone, compile, scan, run the unit test code. So this will be completely taken care by developers. They have to write the test cases and then package and then nexus. So now you are doing minimum testing of the code, minimum scanning of the code, then creating the package and then storing it into the nexus. This is called as shift left and continuous integration. Okay. So if CI is successful, then at least 50% of the work is done. So later you go for deployment. Once CI is successful, then only you will go for deployment. Otherwise, your primary responsibility is to make the CI success, either developers or DevOps guys. So you will run the pipeline automatically. Then this pipeline will get success or failure. If it is failure, developer will get the mail immediately. Then he can check the errors, what is happening inside the CI pipeline. He can check and then clear. Okay. Yeah. Satish Bhavisetti, you have some question?
Hello.
Yeah, hi.
Yes, sir. In the cloning means we are doing that. Like where I worked as for like 6 months or 1 year, I worked as a developer. So what I do, like I work as a .NET developer. Like what I do is like we do take the small packages and we do we do check-ins and checkouts during the developments in TFS.
Okay.
So what the developer will do is like we are doing checking and checkouts, like how what are the things are happening in cloning, like we are pushing that code into Git for cloning, you are saying.
Okay.
In the cloning part, yeah, that's what I'm asking. Like cloning means what we are doing here.
Cloning means is nothing but check out into the Jenkins. For example, you are pushing, how can I compile without having the code? So this clone is nothing but just check out the code.
Okay, what are the developers are doing? They are checking out the code.
You will check in the code into the GitHub. Check-in is nothing but pushing.
Yeah.
So checkout is nothing but pulling. So I'm pulling the code, then I'm compiling it.
Okay.
So without, so I should have the code, right? So this is the checking out the code.
Okay. Okay, cloning is nothing but in Jenkins. From Git, you are getting the code and you are checking out.
Yes.
And compiling that in the Jenkins.
Yes, exactly.
Yeah. After that, again, from Jenkins, we are taking that and we are scanning by using the SonarQube.
Yeah, some tools like SonarQube is popular now. Any tool.
Yeah. So after
just
that,
don't think about the tools when I'm doing this for you sessions.
Yeah.
Just think about the process. Yeah.
Okay. Then after that, again, developers will be doing the unit testing. Maybe it may be manual, it may be automation.
So
Whatever
unit
it may
testing
be,
is
and
nothing but automated. Yeah.
yeah, after that, you are creating a package out of that result, unit testing
Yes.
result.
Yes.
Packages means what? Sorry, here.
If you are Java guy, then .jar.
Okay. That means you are making it as a single file to make
Yes.
that to make it as a build.
Yes. Entire application into single file.
Okay, enter application into single file, and you are moving to Nexus.
Yes.
Nexus
Nexus
part,
is nothing but storage. So like GitHub, you are storing the code. Nexus is
Yeah.
for the storage of artifacts.
Okay, okay. Okay, that is the final stage in CI.
Yes.
Artifact means what? So like here, just
Artifact
like
or package, whatever. Both are same.
okay. So
Okay.
why this Nexus is used like to just to store these packages?
Yeah. So because you are doing hundreds of builds where you store that file properly. So you cannot keep it in your laptops. You cannot keep it in your servers, right? So you will store it in some storage location, that is Nexus.
Okay, just to store this outcome of the unit testing, this package,
Yeah.
we will be using this Nexus.
Yes.
Okay, okay, sir, I understood.
So this is just like a tool to
Repository. We are using it as a repository.
Yeah, repository is
Nexus.
nothing but it is holding something. Repository is the meaning of repository is storing something. So Git is storing source code. Nexus is storing the files. Okay, that's it.
So like Git before what is it? Before compiling, Git is storing, and after compiling, Nexus is storing. You are saying.
Yes.
Like after clearing all the vulnerabilities, like after clearing all the scanning and getting the good result, we are storing that file into Nexus package.
Yes.
Nexus,
So if compile is
repository.
failure, your pipeline
Yeah.
will be failure complete. So it will not move forward. If scanning is failure, it will not move forward. If unit testing itself is failure, it will not move forward. If package is failure, it will not move forward. So if all these stages is success, then only finally we will store it in the package inside Nexus. Okay, so that is the meaning of pipeline. So pipeline is nothing but what is the general meaning of pipeline? You have multiple pipes connected. So you have multiple pipes connected here. If one pipeline is break, then it will not move forward, right?
Yeah.
For example, this is pipeline stage 1, this is stage 2, this is stage 3. Similarly, here in this pipeline, if one stage is failure, it will not go forward. That is why we named it as pipeline. Okay. Yeah. Manoj Kumar, you have some question? Manoj Kumar. Manoj Kumar, are you there? Okay, so there is a question, Mahipal. So scanning will be done before or after the package. So generally, we will first create the package and then okay, so the stages can be anyhow, but the better thing is like this. Okay, so it can be adjusted. The stages can be adjusted as per your project requirement. There is no problem to adjust. Santosh Avla, you have some question?
Hello.
Yeah, hi.
Yeah, hi Shiva. Good morning.
Good
So I
morning.
have I have the two questions. So I'm working on as a DevOps engineer right now.
Oh,
so last 2 years I'm working on that. My question is microservice level. How you build and trigger it is happening in entire project is individually happening. Individually is compiling.
Individually.
In
Microservices, nothing but individual projects.
Yeah, yes, but how you compile entire project is building in and deploy it?
You
Is
don't
how
care
you
about
possible-
entire project. Microservices just care about your microservice only. You're not worried about other projects. So that is why we call them as microservices. For example, in Amazon.in, if the order management is not working, then still the product catalog will work. Customers can browse.
Yeah. Can I ask one question? One more question?
Yeah, yes, please.
Yeah. So one more question is, you have to mention that pipeline script, right? We have to use which script is using scripted pipeline or declarative pipelines. Which script is you
Okay,
have to?
so that is too
Yeah.
much low level discussion. So right now I'm giving you overview sessions, but anyhow, we will go for declarative pipelines, and that is nothing but shared libraries. Okay, we will discuss. We'll discuss in the
Thank you.
sessions. Okay, this is the overview. Just make you understand the concept. Once you understand the
Yeah.
concept, it's completely your wish how you go. Okay, either scripted or declarative or shared libraries, but the concept is same.
Yeah. Okay. Thank you. Thank you, Shiv.
Okay, so this is the continuous integration. So you have the artifact ready. So now we will discuss on continuous deployment. Continuous deployment is once you have the artifact ready, you can directly deploy. You can deploy into dev servers, for example. So what is dev servers? Like we have made our servers ready with Ansible. Okay, so we have created a server, we installed Java, we created Linux users, we created some directories, and using Ansible, you connect to all the dev servers, push the artifact, and then restart the server. Okay, or before that, if you have your application running already, stop the server, remove old artifact, okay, and push the new artifact, restart the server. So this is nothing but continuous deployment. Okay, so you can do this with Ansible, and we have many tools in this continuous deployment. You can use it anything, but the process of deployment is nothing but stop the server, remove the old artifact, push the new artifact, and then restart the server. So this is continuous deployment. And there is something called as continuous delivery. This is a popular interview question. What is the difference between continuous deployment and continuous delivery? Deployment is nothing but non-production servers. Okay, your dev server, your QA, your staging, your UAT, pre-prod, performance, whatever. So this is non-prod. Okay, not exposed to the public, internal to the projects and employees. This is production. Okay. So continuous delivery is nothing but with some approvals. Okay, with some approvals of managers and clients, you will deploy it into production. So that is called as continuous delivery. Okay, that's the only difference, nothing else. So this is finally CI/CD. But before going for production, once you deploy into the dev server, you will have continuous testing also. Continuous testing is nothing but Selenium automation testing. Keep testing. Testers will have Selenium scripts. Okay, so then you configure those Selenium scripts also as part of the pipeline. So then it is called as CD. Okay, so now let us write the CD pipeline, continuous deployment pipeline. Continuous deployment is nothing but deploy and then go for functional testing. Okay, functional testing. So this you will configure as DevOps engineer, but the scripts will be written by the Selenium team or automation testing team. Okay, you don't need to worry how to write those scripts. They will tell you what are the commands to use. Then you just use those commands and create this one, functional testing. And this will give the results. Okay, if pass, mark the pipeline as pass, or if failure, then mark it as fail. Mark it as fail, and you will have the complete report. How many test cases, how many are success, how many are failure, what is the failure reason. This complete report will be referred by the testers and developers. So they will take care. You don't, as a DevOps engineer, you don't have anything to do here. Okay. Yeah, this is continuous testing. So you can have multiple types of testing. Earlier we did unit testing, that is completely taken care by developers. Continuous testing, the owner, the responsibility is with automation or testing team. And another thing we have, it is called as integration testing. Integration testing is nothing but not only a single component, everything. Okay, for example, this is the user component, like user sign up and login. So you have a test cases to test that sign up and login. And once this is done, you can have integration testing. It means that testing complete functionality of your restaurant, like order management, payments, everything. So that is called as integration testing. The integration is nothing but full. You will go for full testing of your entire project. That is integration testing. So once all these things are successful, then you will finally release it into production. Okay, so that is continuous delivery. So, but now can you think, before releasing into the production, how many things we are taking care of? We are cloning, we are compiling, we are building it, we are scanning it, we are running it unit testing, we are running the functional testing, we are running the integration testing, and this is like multiple times, not only single time. Every time developer do some code change, we are testing each and every part of it, maximum from our side. So with this DevOps process, nowadays, the number of defects, the downtime of applications are becoming very, very less. Okay. Naveen Uppalapati, you have some question? Naveen Uppalapati. Manohar.
Yeah, hi Shiva.
Yeah, hi Manohar.
Yeah, as soon as we will be installing like all the plugins there, right? Jenkins, do we need to configure on our own, or by default all this will be configured in the pipeline?
So they will have default configuration. If you want some customization, you can always do it.
Oh, okay. And one more thing, like we'll be going through this unit testing, right?
Yeah.
So developer only will write those unit test cases and will be
Yes, developer will write.
Added it in the code itself.
No, developer will write. So development is completely, it's not our part. So unit testing is also part of development actually. So just by the name test, it doesn't mean like test cases. That is completely taken care by developers.
Okay. No, for those things also we need to have some test cases, right? So that will be also be, I think.
Yes, developers only will take care.
Okay.
But our responsibility is to force them to write it.
Oh, okay.
So through Sonar Cube here, we are scanning the code, right? So there we can calculate how much percentage of code is covered. Like if they have 100 lines of code, so unit testing is nothing but, is he covering this entire code to test? So you can always calculate, you'll get the results in Sonar Cube, how much percentage of unit testing is done. Okay. So here you have some check. At least 80% of the unit testing should be done. So that anyhow you will be the tool will calculate. We don't need to do anything.
Yeah, in that case, so even before going to Sonar Cube, we will be like compiling the code and building right in the maven.
Yeah.
Yeah, at that time we need to see right whether code is passing all the tests. How can we know that?
Unit testing, maybe he out of 100 unit tests, he wrote only 10 unit test cases. Okay.
Yeah. Okay.
For example, and the package is happening properly. But at the time of scanning, if you want to follow the best standards, then you can calculate. You can have some restriction. Okay. So unit testing, this is not mandatory anyhow. Scanning is also not mandatory. But for the best results, we are doing it. Okay. Without doing unit testing, without scanning, also your application will work. But if you want your application to be in a best position, then you need to include these things. Okay. So these are the DevOps best principles. Doesn't mean every company is following this. Okay. So DevOps guys are publishing the guidelines and best standards to the internet. So some companies are following it, some companies are not following it.
Yeah.
Okay. So I'm getting a lot of noise from your side, so that's fine. Muted it. You can message. Venugopal Reddy.
Yeah, hi Shiva.
Yeah, hi.
Yeah, whatever you told is nice, but after this course, at least do one project real time, then we are more understanding what is the real time is doing on.
That's what we are doing. IBM open source RoboShop project.
Okay, that is where
That's a big microservices based project. First, we will deploy it in a single as a monolithic, and then we will deploy it as a microservices.
Yeah, okay, Shiva. That's my question. That's it.
Okay. Sure. Ajay Reddy.
Yeah, hi sir.
Yeah, hi.
For this IBM project, how many instances you are going to create, sir?
Okay, so that anyhow we'll discuss in the demo sessions. This is purely overview sessions. I want to make you understand what is DevOps. Okay, a lot of guys are going to internet and searching DevOps. What is DevOps? You are getting thousands of videos. You are really confused. What is DevOps? Okay, just by 1 hour of demo session, nobody can understand DevOps. That's why I took this overview sessions. Okay, how many instances? How many? Those things are all in the sessions, not in this overview sessions. Okay, but definitely I promise the course is going to be real-time, project-based, completely practical from day one. Okay, Bhargava.
Hi Shiva.
Yeah, hi.
Actually, I don't have more doubts on training because I have some my personal summary doubts.
Okay.
Actually, so I completed my MBA in 2015.
Mm-hmm.
In 2016 to 2022, I have some non-IT experience like mortgage.
Okay.
Now I have nearly 14 months of gap because due to recession, I lost my job.
Okay, so if these kind of questions you have, you can always ping us. Join devops.com, you can find the number, you can ping us there, we will reply.
How can enter into this type of I have experience, how to enter the
just ping us in the WhatsApp, we will send you the solution. Okay.
Okay, sure.
Yeah, thank you. Sattar.
Hello.
Yeah, hi.
Yeah, hi Shiva. Good morning.
Yeah, good morning.
Shiva, like shift left means clone compile unit test package scan, right? Next step.
Yes.
Okay, what is the in the present IT market, automation engineer is getting high package or DevOps engineer is getting a high package? My question. That's it.
I don't have answer to that question. Okay. Automation engineer or DevOps engineer, there is no generalization. Okay. If you have more concept and then if you're highly talented, then anybody can get more package. Even manual tester also, can get more package than anyone else if there is a dependency on him, if he is more important to the project.
No, my question, the DevOps engineer can survive more time, right, compared to automation, right? That's it.
No, we cannot compare two technologies. We cannot compare any two things. Okay, so that is like apples and oranges. You cannot compare apple is good or orange is good. Apple is good in its own way. Orange is good also in its own way. Similarly, we need just DevOps engineer. We cannot run entire IT with DevOps engineers. We need developers. We need testers. We need DevOps and cloud. We need everyone in the market. Okay. So you compare, if you want to compare DevOps and automation, just assume a DevOps guy, he don't know many things in the concept, he's just working. Can he get more package? But automation testing guy, he knows each and everything in the testing. He's doing very well. He is completing his own task before time itself, within 50% of the time. Obviously, automation testing guy will get more package. Okay. So these kind of questions we cannot generalize and then tell you. Whoever knows more knowledge, whoever has more knowledge, and whoever is completing the task in time, definitely will get more package. Thank you. Okay. So finally, today's conclusion is building. You know how to build it, and then the build commands or build tools available for each and every language, and every language has some file. Okay. That is form.xml package.json, and then continuous integration we discussed already. Either you use Jenkins or GitLab CI/CD or GitHub Actions. The process of creating the pipelines are same. You build it, clone it, you compile it, you build it, you scan it, you run the unit test cases, create the package, store it into the Nexus, and you can go for deployment. So deployment, you can do it through the Ansible. The process of deployment is nothing but stopping the server, removing the old artifact, push the new artifact, and restart the server. And then after deployment, you can always include automation testing as part of continuous testing. And finally, you can go for continuous delivery. Okay, so this is about the CI/CD. Okay, as a DevOps guy, you need to configure these CI/CD pipelines. Okay, after this, tomorrow's session, we will discuss about the Terraform and some cloud concepts and something, whatever is required, like Docker and Kubernetes containerization, all those things we will discuss in tomorrow's session. Okay, so our training starts from July 30th. So you can see here. So I mentioned each and every detail in this website, joindevops.com. When is the demo, when is the classes, duration, and dates, and the features like GitOps. We are following complete GitOps and completely real time. We will have multiple environments. We will help you in resume preparations, and we have Slack channel to discuss the doubts, and we have dedicated Q&A sessions. Everything we have. So that takes 3 to 3.5 months. So whatever the concepts we are discussing here, so we will do it with a real-time project from IBM. Okay. So not at the end of the training, but before, from the day one of the training, we will completely work on real-time project. So end of the course, so we will achieve all these things. When developer commits a code into the GitHub, so automatically we will run these pipelines and we will deploy the project successfully. That is our goal. And we will have some monitoring also. Yeah, one final question, Vishwanath Reddy. Just 1 second, finding you. Can you raise your hand, Vishwanath Reddy? Yes, you can speak, unmute, and then ask.
Yeah, sure. Regarding that, after completion of course, how to prepare a resume and what about material and questions and answers like that?
Yeah, we will discuss in the sessions. So just understand one thing. If you are strictly preparing for interview question and answers, if you are taking the training based on interview question and answers, definitely other side person can easily find you. So you prepared for the interview and you came it. But our training is like you are working as a DevOps engineer. For example, if we directly recruit you into a DevOps engineer without having any experience, how you will configure the project from the scratch. So that is what I'm going to teach. So an internet interview preparation is already a subset of our training. Okay, that is by default.
Okay.
If you know how to do practically, how to configure the project using DevOps practically, then by default you have the interview knowledge. Okay.
Sure.
So that's all for today. Thanks for joining. Have a nice day. See you in tomorrow's session. Bye-bye.
Thank you.